Good morning, students. Welcome back to the series of digital electronic class. In today's class, we are going to do some numericals based upon the mean term and max term, the conversion of mean term to max term to mean term, and some problem related to these topic only, because it will ask for 5 marks questions and it will keep on asking these kind of questions for long answers. So for these purpose, what we'll do it, we'll try to take one Boolean functions, we'll find out its value. So for doing these things, what we'll do, we'll try to find out some problems. So like that, first problem I'm taking, take a Boolean function f of a comma b comma c of a complement b plus b complement c plus ab. That's my question. The question over here is, take this Boolean function and convert into respective mean term and max term. The question over here, they did not mention the complete literals. So first thing is that we need to take this number, this expression of Boolean, and we'll try to convert into mean term and max term. So in order to do these things, what we'll do, we'll take the function. First thing, the solution of this would be f is equals to a complement b plus b complement c plus ab, right? So for this thing, what we'll do, first thing is that here in first literal ab is there, but we don't have any number, right? What actually it needs to have, it should have 3 values, because if you want to write a complement b complement c complement, then it would be mean term m0. If you want to write a complement b complement c, it would be mean term m1. Likewise, a complement b c complement, it would be m2. So small m2, m3, m4, m5, m6, m7. So what would be the m7? A, B, C, because 1, 1, 1. So likewise, we'll write all those values. That means for every respective term, all literals needs to be present. So here we don't have the C, so we'll multiply with 1. Similarly here we don't have with A, so we'll multiply with again 1. In the next term, AB is there, we don't have the C, so we'll multiply with again 1. So what is the expression now? So what is this 1 I'll write, we know that C plus C complement is what? It's 1. Similarly for the second term, what I can mention, A plus A complement, I can write it as 1. For this, what I'll write, again C is there. So these two Boolean laws I'll apply in order to convert this respective question. So in order to do these things, what I'm doing, I'm writing A complement B. What is this? 1 is nothing but C plus C complement, plus second one B complement C as it is. What is 1 I should have to mention? B is there, C is there. Which term, which literal is not there? A is not there. So we'll multiply A plus A complement, plus we do have AB here. What is not there in this? C literal is not there. So we'll multiply AB into C plus C complement. So what is the next criteria? We need to just multiply with this common factor with both. So what actually the answer? So A complement B C plus the same factor multiply next with C complement. So what I can write? A complement B C complement plus this factor will multiply with first as well as with second. So what I'll write over here? A B complement C plus this multiply with this factor. So A complement B complement C plus, so this next factor. What is the next factor we had? ABC plus ABC plus next with the second factor ABC complement. So this expression now can be written in this form. So see, anything is repeated or not. So as per the condition, what we had the first A complement B C plus next what we had, A complement B and C complement, plus next we had A B complement with C, plus next A complement B complement with C plus ABC plus AB C complement. So these are the terms we get. Next thing is that we need to write it with respect to its mean term. So what I can write for this? So what is this A complement BC means? 0, 1, 1. So 0, 1, 1 is 2 plus 1, it is 3. So I can write its mean term M3 plus next one 0, 1, 0. So 0, 1, 0 is what? M2. So mean term M2 plus next 1, 0, 1. 4 plus 1, it's 5. So what I'll write for this? M5. So 0, 1, 0, 1. So 1 is what actually? Digit is what? 4, 2, 1. So 4 plus 1, it's nothing but 5. Plus 0, 0, 1. So what I can write for this? M1 plus 1, 1, 1. That means M7 plus 1, 1, 0. That is M6. So in short, what I'll write in specific order what I get first thing. So this is my mean terms I do got. So I'll write summation of M of all the numbers. So what I'll write for this first number? We do have this 3 is there, 2 is there, 5, 1, 7 and 6. So I'll start from 1. So 1, comma 2, comma 3. The next is 5, 6 and 7. So this is your mean terms. So what we found just now? We found mean terms. So similarly, we need to write its max term. So max term in the sense, the terms which is not present in the mean term that resembles it is there in the max term. So what I'll write for this? If the same function I need to write for max term. For that what I'll write? What is the max term presentation? With pi capital M of. So how many variable it is? It's variable of A, B, C. That means it's 3 variable. 3 variable means range is from 0 to 7. So what is the range, the values from it? 0 to 7. So 0 to 7 would be there. So that means, do we had 0 bit? No. So 0 is there in max term. Next, 1, 2, 3. Do we have 4? No. So 4 is as it is. Next, do we have 5? Yes, 6 and 7. So this is in what, which form it is? It is in max terms. So how do we mention max term for this? So this is mean term, this is your max term. So this answer we got for mean and this answer we got for max. For max, how do we mention 0? 0 is nothing but A plus B plus C. 4 means, what is 4 for max term? 4 means 1, 0, 0. So 1, 0, 0 would be A complement plus B plus C. So that is what this function has been written in mean term and max term in terms of numbers or in terms of literals. So this is how your question for conversion of mean term as well as max term can be obtained in this way. For next problem, we will see how to solve the questions based upon your max term. Based upon the max term, we need to solve it. We'll take one more problem and same thing, how we'll do it, let us see. So see student, next problem. So they gave the question f is equals to summation of this one. They asked to find the complement of the function. So complement of Boolean function we need to find out. So this is the another way of asking the question. So here is they gave in terms of summation. They asked to find the complement. Complement means what? They gave summation, that is mean term. We need to write in terms of max term, pi. So you can take this thing. So the numbers are from 2 to 14. So what I can write for this? F is equals to mean term M2 plus M4 plus M7 plus M10 plus M12 plus M14. So these are my mean terms that I need to write in terms of max. So in order to do these things, what I'll do it? I'll find the complement. So complement of this would be F complement is equals to. So since you can see the terms, it's 2 to 14. That means it should be 4 variables because the range are from 0 to 15. That means it's what? 4 variable. It can be A, B, C, D or it can be any other alphabet. So since I'm taking A, B, C, D over here, so I'll take the complement of it. So what is this? They start from 0. Do we have 0? No. That means mean term M0 in product form. Similarly, 1 is there? No. So it's M1. M2 is there? Yes. Then M3 is not there? We'll write M3. M4 is there? Yes. M5? Yes. Then M6. M7 already is there. M8. M9. 10 is there, M11, M12 is there, 13, 14 is also there, M15. So this is your complement of that Boolean function. So what I can write for this? So F complement is equals to product of 0, 1, 3, 5, 6, 8, 9, 11, 13 and 15. So likewise you can write the literals in terms of ABCD you can write, or you can write this much only. So they'll ask for, this is 2 marks question. So take the complement of the function and find out the value. So next same way we do have this question. So here they gave again, they asked to find the complement. So in order to do this complement, what we'll do? We'll take the function complement. F complement is equals to the pi. So what is the pi term? Before doing this, what we'll write? We'll write in terms of pi. So before taking complement, what we'll write? We'll write F. So F is equals to product from M3 into M5 into M7. Or you can represent in terms of ABC. What is 3 means? It's what? 0, 1, 1. 5 means 1, 0, 1. 7 means 1, 1, 1. We'll write in product form. What we'll write? A plus B complement plus C complement into next term. What is the next term I do have? I do have 1, 0, 1. So 1 means A complement plus B plus C complement into next 1, 1, 1. That means A complement plus B complement plus C complement. So we got these terms. So next thing is that we need to write its complement. That means your product term needs to be written in terms of summation. So what I'll write? Take the complement of the function. So F complement is equals to this pi, will make it as into. So what I'll write? M0 plus M1 plus M2. M3 is there already. M4, 5 is there. M6. So that F complement would be summation of 0, 1, 2, 4 and 6. So this is your complement of product term to sum to product term and product to sum terms we have done. So in the next problem we'll start this same thing by taking the universal gates and by using the K-maps. The next topic for our discussion would be the K-map or Karnaugh map, or in short we call it as, this thing is nothing but like a K-map. So what is the use of this K-map? Why the K-map has been introduced? The reason is that the digital circuitry, the complexity of the digital circuitry we need to eliminate. That means if you do have many functions, like you do have functions of 3 variables, 2 variables, 1 variable, those functions you want to implement at one end. So what you will do it? You will require a lot of bits, we can say a lot of hardware we required in order to go for gate level designing. We don't want all those things. We want a specific map or something like which can reduce the complexity of our digital circuitry. So that in order to achieve this thing, so we are proceeding with one next topic is called Karnaugh map or K-map. So the first thing, it starting from 2 variables. So if you do have 2 variable K-map, what is the meaning of that? So 2 variable in the sense we are using A first. Suppose for example I am taking another variable is B. So what is the 2 variable combinations? So 2 means the combination of bits would be, the combination of bits, what I can write for this? It's 2 power n. So 2 power n is what? 2 power 2, it is 4. That means digits starting from 0 to 3. So that is a combination of these 2 variables. So how do we represent? So we are saying it is a map form. So we'll represent each bit, like each bit of it with a one specific square box. So how many square box we required for this? How many combination? 4 combination. That means we required 4 square boxes. So like this will represent 4 square box. Clear? So here we'll mention those combination. What is this first bit? We are saying A. Second bit we are saying B. So what is this first combination of two variable? A, B if you do have, it's 0, 0, 0, 1, 1, 0, 1, 1. That means this is there for mean terms. Whatever the K-map we are taking, it is always use only the mean terms. So M0, M1, M2, M3. So this is the mean term we know for 2 variable. We want to write that in terms of K-map. So what we'll do it? We'll take this square form. Each square box represent what? Each square box represent one mean term. So here what I will write? First combination is what? 0, 0. So this is 0, 0, 0, 1. Then what is the value for this M0? So suppose this is 0, 1, 0, 1 I'll write. So this is 0, 0 means it's M0. 0, 1 means it is M1. Right? So 0, 1 is, what is the mean term? M1. Next is 1, 0. Why I'm taking like this? Because A indicate this part. Whatever the portion is there, this is the for A value. And this portion is there for B value. So what is this first box combination? 0 and 0. This is the first box, right? Consists of these two zeros. This is the mean term M0. Likewise, we do have next one 0 and 1 for the next this box. So this 0, 1 means its mean term M1. Likewise, we do have next box. What is the next box combination? 1, 0. So what is 1, 0? M2. Next is M1, 1. That is M3. So 1, 1, we wrote it M3. So this is the representation of two variable K-map. So what is the advantage of using these K-maps? Because whatever bits we had, we'll try to take that in terms of implicants. That implicants, when we'll do the problems, you'll come to know. The combination of your single unary, 2 bits binary, or 4 bits or 3 bits, that combination, when we'll do the problems, you'll come to know in detail. So likewise, this we have designed for how many variables? 2 variables. This is the pictorial representation of that into the square boxes. So what is the conclusion of this thing? What after learning this, what you know? You know that first, K-map is used for simplification of complex circuitry in digital systems. So in that, if you do have 2 variables, we are mentioning as 2 variables as A and B. So total combination of A and B would be 4. That means mean terms start from M0 to M3. So that mean terms, each mean term represent with the help of one square box. Total combination would be M0 to M3. So each box resembles one specific mean term. So this is 0, 0 means mean term M0, 0, 1 mean term M1, 1, 0 M2, 1, 1 is M3. So likewise, if you want to design the 3 variables. For 3 variables, what we'll write? We'll write here. So it's 3 variable K-map. So 3 variables means, suppose how many variables I'm using? A, B, C. So this is 3 variables. Total combination is 2 per 3. That means total combination is 8. 8 means bits are starting from 0 to 7. So how many boxes we are using? Suppose the pictorial representation of this thing would be like this. Right? So but how many bits we are using? 3, right? So here I am mentioning A, here I am mentioning B and C. This is the first box, second and third. Like this we represent. So what is A? What is the maximum value of A? It can be 0, it can be 1. What is BC? 0, 0, 0, 1, 1, 1, 1, 0. Like this we are representing. What is the first box? M0, M1. Here M2, here M3. Then this side M4, M5, M6, M7. How do I mention this thing? By seeing the each box. So as you can see here, first we are taking 0, 0, 0, 1. Next has to be 1, 0, but we are not writing 1, 0. We are writing 1, 0 here. Then 1, 1. So we proceed like this, like a folding. How do we fold? Like if you do have one paper, you try to fold that paper. So how do we fold it? From front end, from the back end. So if you see M0, how do we M0 will write? A and BC. What is M0 combination? 0, 0, 0. Next M1. What is M1? 0, 0, 1. So if you see the truth table of this 3 variable, if you do have A, B, C, 0, 0, 0. So this 0, 0 indicates M0. If you do have 0, 0, 1. What is 0, 0, 1? M1. If you do have next 0, 1, 0. What is 0, 1, 0? M2. 0, 1, 1. It would be M3. Likewise, what is the maximum value? 1, 1, 1. 1, 1 means M7. So like this, we'll write all these combinations. So in this way, first I want to get M0. How do I get M0? First 0, 0, 0. All zeros, then it is M0. Next M1. So 0, 0, 1. That is M1. Next 0, 1, 1. What is 0, 1, 1 combination? So 0, 1, 1 is M3. That's what it is written, M3. So 0, 1, 0. It is M2. So that's what you got. M0, M1, M2, M3. Here also M4, M5, then M6, M7. So this is the way of representing your 3 variables K-map. So in this 3 variable K-maps, what you have taken? You have taken a square box. Each square box represent one mean term. So when you want to see this square box representation, every box have the 3 values, 3 digits from to truth table. So from that truth table, you have mentioned all those bits and you have written its respective mean terms A, B, C. So based on this 2 variables, 3 variables, even the 4 variables K-maps, we'll try to combine the number of bits and we'll try to take the redundant bit and we'll try to find out the solution for it. So likewise, we'll be having the 4 variables. Let's see the 4 variable K-map, how we'll design. So based upon the designing part, we need to write it. So based on the writing part, we need to, what we'll do, we need to mention 4 digits for 4 combinations. Students, so we'll see the 4 variable K-map. So in this 4 variable K-map or Karnaugh map, first thing is that I'm mentioning those 4 variables in terms of A, B, C, D. This is my 4 variables. Okay, so total combination of 4 variable would be 2 power 4. That means 16, 0 to 15. So now what I'll do, each square box represent one mean term. So how many mean terms we do have? We have 16 mean terms starting from M0 to M1. Likewise we do have M15. So we'll mention all those in terms of boxes. So like this we took the box. So 1, 2, 3. So 4 columns we prepared. Likewise we'll take 4 rows. 1, 2, 3 and 4. So we prepared 4 rows. So each rows, so that each rows, what I'm mentioning one specific letter for it. So that each rows is what? A, B. This is the values which we are writing this combination. Next is C, D. This side I'm writing. So what is AB to, if you do have AB value, what is the AB total combinations? 0, 0, 0, 1, 1, 1, 1, 0. Similarly for CD, only 2 bits means 0, 0, 0, 1, 1, 1, 1, 0. So important thing is that 0, 0, 0, 1, 1, 1 will come, then 1, 0, because it's a folding one. So what is the first block represent? M0. Next block M1. Next here is M2 and M3. So likewise we'll proceed this forward, this will be from back to front. Next this side, what I'll write for it? 0, 1, 2, 3. Next this would be 4, M4, M5, M6, M7. Similarly, we'll start here. We'll not go for this column. We'll proceed for this column first. So 0, 1, 2, 3, 4, 5, 6, 7. Then 8, 9, 10, 11, 12, 13, 14 and 15. So how do we have taken? From this end to this end, from this end to this end. Now check whether it is proper or not. So what is the M0 means? All 4s will be zeros. Next M1. M1 would be 0, 0, 0, 1. That is M1. Next M2. What is M2 will be? 0, 0, 1, 0. So you should know the truth table of 4 variables. What is 4 variable truth tables? If you do have A, B, C, D. If you want to represent, what is a representation of it? It's mean term. How do we mention mean term? M0, M1, M2, M3, likewise M 15. What is M0? All bit would be 0. It's 1, 2, 4, 8. 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this would be next one, M1. What is M1? 0, 0, 0, 1. So we got M, mean term M0, M1. What is M2 we'll write? M2 will be, this means 2 would be there, 0, 0, 1, 0. M3, 0, 0, 1, 1. Likewise, if I want to write M12, how I'll write M12? Your so many bits are there, you need to write all for your reference. I am taking this thing. So what is M12? 12 means 8 plus 4. It's 1. 4 is also 1. This is 0, 0. In between all are there. M4, M5, M6, M7 till M12. Likewise, M15, what I'll write for M15? 1, 1, 1, 1. So this truth table you need to keep in your mind while you're solving the problems. For this thing, what we'll do? We'll take A, B, C, D. It's M0. That is the first bit. 0, 0, 0, 0. M1 is 0, 0, 0, 1. That is written. Next, if you do have 0, 0, 1, 1, it is M3. So how we have mentioned? We mentioned from 0, 1, 2, 3, 4, 5, 6, 7. So what is 7 should be there? 0, 1, 1, 1. It is M7. Likewise, from second end. So how we are folding? If you do have a paper like this, if you try to fold from this is from front end, this is from back end. Then from the bottom, from bottom, back side. So this is the way we'll fold it. So by taking that folding concept, this is the four variable K-map has been designed. So by taking these 4 variables, 2 variables, 3 variables, we'll do some problems. Based on those concepts, we'll try to solve mean terms of the Boolean function by giving the expression, by giving directly numerical numbers. So thank you for today's class. In next class, we will see complete detail about these functions.